Let's take a look at a really interesting topic of compound interest. And before we do that, we're going to talk about interest rates. So interest rates are usually given as an annual percentage rate, otherwise known as APR. Okay? And all that means is it's an interest amount. It's a percent per year. It's annual, so it's per year. Percent per year, okay? Now, when you look at something called compound interest, the idea is you have a certain amount of money and on regular intervals, interest will be added back to that amount of money and then it will gain interest on that new amount, okay? So that's the idea. So you start with your principal. That's the initial amount, the principal, and then you add on a little bit of interest. You add on a little bit of interest, and now all of that turns into your principal. And then later, that whole thing adds on some interest, so you get even more interest, and that all turns into your principal. And then you keep tacking on more interest every time the interest is what we say compounds, every time the interest compounds. And so the amount of money, the principal keeps growing at regular time intervals, okay? So that's this concept of compound interest. Interest rates can compound at different points in time. So the standard is to identify an interest rate in terms of how much percent per year, and then you adjust it based on how often the interest actually compounds. So let's talk about different ways that interest can compound. Let's use an example. Let's look at, let's keep it simple. How about 8% APR? Okay, 8% APR, annual percentage rate. What we're going to do is we're going to convert this to different interest rates. Let's look at 8% APR means if you were to look at a picture of that, let's use blue. If you were to look at a picture of that, here's your 1 year period. That's 1 year. So 0, and then you've got 1 year. You got 8% spread out over the entire year. 8% spread out over the entire year. And if you want to convert this to smaller time frames, such as semi-annual interest rate, and semi-annual just means every 6 months instead of every year. So if you think about this, that means, all right, if I take this 8% per year and ask how much is it over half of a year, let's say it that way. Yeah, that's okay. Half of a year, 6 months, right? Then when you convert it, you get 8% divided by 2, which equals 4%. So an 8% APR is the same thing as a 4% semi-annual interest rate. And when you look at a semi-annual interest rate, that means your principal is going to compound every 6 months. So after 6 months, 4% is going to be added back onto your principal. Okay, so in this case, in the 1 year period, if you're looking at 8% APR and it only compounds at the end of the year, you've got your principal, and then at the end, you've got your principal plus your interest. One time, 8% plus 8% interest. When you look at semi-annual, you're going to start with your principal, and then you're going to add interest here, right? And then after another 6 months, you're going to add interest on top of all of that, even a bigger interest. So it would be better for your money, for your interest rate to compound more frequently, even though on smaller intervals, the interest rate is lower. It's only going to compound by 4% in 6 months as opposed to 8% over a year. And they're not going to be the same number, by the way. All right, let's look at another example. So that's semi-annual, which means twice per year. We have quarterly interest rate. That means every quarter. That's every 3 months. There are 4 quarters in a year. So when we look at that, we're going from 0 to 3 months, 1/4 of a year. So when you're comparing this to your original, you would take your annual percentage rate of 8% and you would divide it by 4 because there's 4 quarters in a year, which means every 3 months you're going to compound by 2%. But that's going to happen 4 times over a period of a year that you're going to add the interest back. Okay? Let's look at monthly. Monthly interest rate. You're going from 0 to 1 month now. And you can imagine in that case, you're going to take your annual divided by 12 because there's 12 months now. And that's going to be, let's see, 2/3 of a percent. You could write that as a decimal if you want, but 2/3 of a percent. But that's going to happen every month for 12 months, and that's going to be better for you than if it compounds once at 8%. Okay, last we have daily interest rate. Now this one's kind of unusual. Daily interest rate. So we're going from 0, and I'm going to make it kind of big here just so we have room to write. You're going to go to 1 day. Now the tricky part about this calculation is for financial purposes to make the numbers easy to work with, rather than dividing your interest rate by 365, because that's how many of these time increments are in 1 year, they divide by a nice close number, 360. So here, you're going to take your 8% divided by 360, which is literally 8 over 360 reduces to 2 over 90, 1 over 45. So it's 1/45 of a percent, and that's per day. Every day, your interest is going to compound by 1/45 of a percent. And over a period of a year, it's going to compound really 365 times, right? Because there's that many days in a year. Here, this is per month, because that's your monthly interest rate. This is per quarter. This is per 6 months or per half year. And all the way back up here, this would be per year. Okay, so I want to straighten out all the different ways to interpret an annual percentage rate and adjust it. These guys are what I'm going to refer to as an adjusted interest rate, depending on how often your interest is going to compound. Okay, let's do some practice actually calculating some things. So let's use a very basic example to get started. Let's say that we have principal of $5,000. So that's how much you have in the account at the beginning. Principal of $5,000 at an APR of, let's be realistic, maybe the APR is only 3%, okay? An APR of 3%. Compounds monthly. Let's ask the question, how much in the account after 1 month, okay? And this is a simple example to motivate the idea for when they get tougher. So what we need to do is, we have an interest rate of 3% per year, but this interest compounds every month. So I need to convert it to a monthly interest rate. And if I think about that 3% spread over an entire year, How much does it turn into if I look at just 1 month of that? Well, it's 3% divided by 12 months, which equals 3 divided by 12 is a fourth. So it's 1/4%, or 0.25, okay? 0.25%. As a decimal, that's 0.0025. You move the decimal to the left 2 places. So there's a couple ways to look at this. If you want to figure out this much per month, 0.25% per month is going to be added back on. Well, you take your principal times, you don't multiply it just by the 0.25%. If I take 5,000 times the interest, then that's just going to tell me how much is added back into the account. So a better way to do this is to multiply it by 100.25%. What that's going to do is it's going to take and it's going to incorporate the original 5,000 because you're multiplying by 100%, but then you're also multiplying the 5,000 by the additional interest, the 0.25%. Okay? So if you want to calculate that, on your calculator, you might do 5,000 times, move the decimal to the left 2 places, which is 1.0025. Okay? Now, again, I'm trying to motivate the idea. I hope this makes sense that if you just multiply by the 0.25%, you're just going to get the interest that's added. And that would be fine. You just have to add your 5,000. And we could totally do that. But what I'm wanting to do here is build the concept we'll use for these compounding problems. So try to follow along. Now, you could multiply this and get your answer. I know that. But that's not the important part. What we're going to do now is this is really helpful to separate the 100%, the original principal, from the interest percent. So when I do that here, the 1 is my 100%. So I'll copy that down. And then everything after the 1 is my interest. So I'm going to write plus 0.0025. Okay? And so what this is this is your 100% that you're multiplying by the 5,000. Right? 5,000 times 1 is 5,000. You get the 5,000 back plus your interest. And so you can visually see the original plus your interest if you split them apart like this with addition. And so now if you calculate that, you get $5,012.50. So after 1 month, that's how much you'd have in your account. Okay? Now, let's ask a harder question. Let's ask, we still have the same setup. $5,000, 3% per year, compounds monthly. But now I'm going to say, how much will be in the account after 8 months? How much in the account after 8 months? Okay, so here we go. We already know, because of the previous problem, that our monthly interest rate, so 8% APR, equals, 3% APR. 3% APR per year equals 0.25% per month. Okay? So here's the idea. You're going to start with your principal, which is $5,000. And then after a 1 month period, after 1 month, you're going to take the 5,000 and you're going to multiply it by 1 plus your monthly interest rate, which is 0.0025. Okay? So this is, again, 0.0025. Now, we're not actually going to calculate that. This is what you have after 1 month. After 2 months, this now is your new principal. So now you're going to take this entire thing, 5,000 times 1 plus 0.0025. You're not actually going to calculate that. Don't calculate it. That's your new principal, and you need to multiply it by 1 plus your interest. Okay? And so this ends up equaling 5,000 times 1 plus the 0.0025 times another 1 plus the 0.0025, which means it's multiplied by that principal plus interest squared. Okay? And so hopefully you can imagine what this looks like after 3 months. After 3 months, you're going to have 5,000 times one more of these. So you're going to have 5,000 times 1 plus the 0.0025 to the third power. And if we continued this process on and on and on, then after 8 months, you would get your principal times 1 plus your adjusted interest rate 8 times, because it would have compounded 8 times after 8 months. And now you can put this into your calculator all at once rather than calculating all the individual months in between. And this to the 8th power. It looks like we get about $5,100.88. So if it compounds at 3% per year, but it compounds monthly for 8 months, this is how much you would expect to have in the account after those 8 months. Okay, so that's an example. Let's do another one now that we have the concept. And let's deal with uglier numbers so you can see the benefit of doing the 1 plus your interest rate. So now let's say we still have $5,000, an APR of 2.3%. 2.3%. Compounds daily. How much after 200 days? Okay? All right, so here we go. The first thing we need to do is adjust our interest rate. So I need to take 2.3% and make it a daily rate. So I need to take 2.3% divided by 360, okay? Divided by 360. Now, 2.3% is the same thing as 0.023 divided by 360. What I'm going to recommend is don't calculate this. It's going to be an ugly number, I'm sure of it. So instead, leave it like that. That is our rate. We're going to let the calculator do all of the work at once at the very end of the problem, okay? But now you've got the tools you need. So you're going to start with $5,000, and then after one day, you're going to take that principal of 5,000, and you're going to increase it by this much. So you're going to do 1 plus this adjusted interest rate. 1 plus that adjusted interest rate. So this is after 1 day. If I do it again, I'm going to multiply this new principal amount by this increase again. So it'll be 5,000 times 1 plus my adjusted interest rate times that one more time. So that would be after 2 days. And so hopefully you can start to see that if we continue the process after 200 days, we'll have 5,000 times 1 plus the adjusted interest rate 200 times. 200 times. And if I were to put that into my calculator, see, I'm going to let my calculator do all of this for me at once. Rather than figuring out this nasty number and rewriting it, I'm just going to let my calculator do it all at once. So 5,000 times the quantity 1 plus the fraction 0.023 over 360, close the parentheses, raise that to the 200th power, I would get approximately $5,064.30. Okay? So there are multiple examples of compound interest. We talked about semi-annual, quarterly, monthly, and daily. Okay? And you can see how if you're not compounding yearly, then you have to adjust your APR. And we talked about how to do that. So you're always going to take your principal times 1 plus your adjusted interest rate, and you're going to multiply by that 1 plus your adjusted interest rate as many times as the interest compounds in the time period, which in this case was 200 days. It's compounding daily, so it's going to compound 200 times. Okay? Let's try another example. Let's reuse some of this information. So now, principal of $5,000. Let's keep the APR the same. Let's say it compounds quarterly. Compounds quarterly. How much after, let's say 10, I want to do this example because I'm not going to say quarters, I'm going to say 10 years. Okay? So the adjusted interest rate needs to be quarterly. So the quarterly rate now is what we're going to work with. So I'm going to take my 2.3%, which is 0.023, and divide it by 4. Because it's 2.3% over a year. In a quarter, I divide that by 4. So what I'm going to do is take my principal times 1 plus my adjusted interest rate. And I need to figure out how many times this guy is going to compound in 10 years. Okay? So this number right here is how many times it compounds. So 10 years equals, how often are we compounding here? We're compounding every quarter. So the question is, how many quarters are there in 4 years? Or 10 years, I'm sorry. So if every year has 4 quarters, then 10 years is the same thing as 40 quarters. So that means we have to raise this to the 40th power because we're going to compound 40 times over that 10-year period. And again, just so you can double check that you're getting this correct on your calculator, 5,000 times the quantity 1 plus the fraction, 0.023 over 4, all of that raised to the 40th power is approximately $6,288.86. Okay? So 10 years of earning interest quarterly at this APR yields this much in the account at the end.